I am Sai Nikhila. Today I am here to share the things that I have learned and experienced in my summer internship 2025. I have done my internship for a period of 2 months, that is from May 19, 2025 to July 18, 2025 in the Department of Ocean Engineering, IIT Madras. I have done my internship under two professors. They are Professor Paneer Selvam sir and Professor S. Abhilash Sharma sir. So in my internship, I learned different aspects related to the autonomous surface vehicles. So I have learned how to simulate a vessel in a ROS software, in a ROS operating system, and I also learned, experienced the experiments. I involved in turning circle experiments and learned the practical knowledge from the research scholars there. I also performed some simulations, frequency domain simulations in a Hydra website. It is an open source web page. And I also learn about the sensors, the calibration of the sensors. I also performed the calibration of the wave probe sensor. And I also reviewed and presented a presentation on a Naval wave energy converter. These are the overview of the things that I have learned in my internship. So, at first, Professor Abhilash Sharma sir shared us a lecture notes, like it was maneuvering and control of marine vehicles. It consists of the lecture notes and the tutorials. This is a semester program which they conducted in IIT Madras for 5-year students. In this tutorials, I have learned the kinetics, kinematics, and the linearized maneuvering equations, open control, open loop control, PID controls, and different things that will help us to simulate and create an autonomous vehicle. So that was coming to the lecture notes, and in the tutorial part, we will create an autonomous surface vehicle, artificial, a virtual surface vehicle, and we simulate the vessel with the help of Python code. So before going into the creation and simulation of a vehicle, we need some important computer applications. Those are the Docker and the GitHub. Docker is a containerized platform. It helpful in a way that everyone will work in a Python code. If my version is version 2 and my friend is working on version 3, there will be some version control problems while running the code. So this Docker, what it do is, this we can package the whole version, the whole software into a container, and the container can use by everyone in the team. So this helps to minimize the version errors and similar running errors similar way. And this increases the collaborative teamwork. And the next software tool is Git and GitHub. Git is a fast, scalable, and free source and open source to everyone. It is a control version system. That means it tracks the code. If the present code you are running is wrong and the past code which I have learned in the past is correct, then we can have the chance to go to the past code and we can rerun again. So it gratefully helps in collaborative teamwork, and my code can be seen from the team members, from my team members, and etc. And whereas GitHub is a cloud-hosted Git service that allows developers to store and manage the repositories, which means the folders that we can store our Python codes. Next, in the tutorials, first we have to create a vessel, a virtual autonomous surface vessel. So to create that vessel, we have used Python code. We have used VS Code application to create the vessel. In this vessel, we created a vessel with the help of Python code, and we operated that with two switching rudder control systems. One is fixed, and another one is switching rudder control. Fixed means we will fix the rudder angle, for example 10 degrees, 35 degrees, etc. And we will run the vessel and we get the plots. In switching rudder control, we will switch the rudder angle, for example from -10 degrees to 10 degrees. Minus means from port fixed rudder control, when I run the code with a 5-degree rudder angle, I get this circular path. That is the vessel path, the vessel in which it could travel. And this is the rudder angle, velocities, heading angle, and turn rate. And next one is switching rudder control, which I have changed my rudder angle from -4 degrees to 4 degrees continuously. And I got that spiral vessel path. And okay, now here we have the virtual autonomous surface vehicle. But in real, if we conduct the experiments, we will use sensors to track the vessel's position, rotation, velocities, acceleration, etc. So in simulation also, we placed IMU and UWB sensors on the surface vehicle. So what these sensors will do is, IMU sensor gives the acceleration, position, and the rotation with three different types of sensors in it. And UWB sensor will give like if we are conducting an experiment, autonomous surface vehicle experiment in open area, we will get transmitting the signals information using a satellite. But when we are conducting in a closed area, in a closed wave basin, you don't get access to the satellite information. So we will use this UWB sensor to send the messages and receive the messages from the sensors on board, which are on board the vessel, to the systems. So we places the virtual sensors, and these virtual sensors are tagged with the real information, real IMU vessel information, and we simulate it and we run the vessel in artificial sea. Before this, before placing those sensors, we have to create a ROS environment. ROS is nothing but a robot operating system. ROS is basically used in robot systems like drones, etc., which will use by robot or this something like that. So what will this ROS do is, we have different, like the motherboard. In the motherboard there are different microprocessors, microcontrollers, to the actuator, rudders, propellers, etc. So we have to connect all these with something, right? So this ROS to connect all these applications, like transforms the microprocess signals to the rudders, and the rudders, the actual rudder commands to the a system. So this ROS2 will create an artificial like sea, which have nodes, and the information through the nodes will be carried as topics. So this publish messages. Publish means someone is speaking, and subscribing means someone is listening. So this ROS2 will help sending signals and receiving signals from one part of the mission to another part. So all this ROS2 information is created using Python language. So these are the publishing messages from the like rudder command or something from the virtual environment. Next to place the sensors, IMU, UWB. Next to simulating the sensors with the sensors, as I mentioned earlier, we will attach these sensors with some real information, real sensor information, and we run the virtual surface vessel with this real sensor information. After simulating using sensors, we will get these plots. Those are the IMU data which we obtain: acceleration, velocity, and Euler angles means the rotation, and this is the UWB data. Next, open loop control. Okay, now we have a vessel with the required sensors, but the ultimate goal of ours is the vessel should go in the path which we have pre-designed to it. So in open loop control, we will assign a path. It means a circular, spiral, zigzag, whatever it is, we will give a pre-planned path, and the vessel should travel in that path only. So open loop control, we will give the Python code in such a way that the vessel will travel in the given path only. So these are the three paths which I have tried, that is turning circle, this is zigzag, and this is the spiral path. And the next one is PID. In real, in ocean, if the vessel have to travel, it have to decide on its own, right? Autonomous means it have to decide on its own based on the circumstances. So what is PID loop control means? It's a programmable derivative and derivative. Integrative and derivative control. This means it will read the current actual rudder command, and also it fixes the current rudder command to the desired rudder angle. So for example, my desired rudder angle is 30 degrees, but my actual rudder is 10 degrees. It will do some mathematics and calculation. It will try to minimize, it will try to bring the 10 degrees rudder angle to 30 degrees. This is what this PID loop control will do. After simulating with this PID loop control, we will get this results. This is the path which I have given to it, and the vessel is traveling according to the path, changing according to the desired rudder angle. So up to that is the lecture notes and the tutorial which sir has provided to us. And this is another topic. This is hydrodynamic response analysis. It is an open source website, a web page which was created by the Naval Marine Autonomous Robotic Laboratory under the guidance of Professor Adlas sir. What does this hydro do is it can perform linear and non-linear simulations in frequency domain and time domain. But currently the time domain analysis is still in developing phase. In frequency, we can do frequency domain analysis for those linear and non-linear analysis on a ship. It is so user friendly, means it only takes two files. One is the mesh file, that means the geometry which we can directly import from Rhino, and another one is the input file. In input file, we will give them required values like the ship place in the ocean, in the space, and the weather speed, etc. The required values. That's it. If we give the two files, we can simulate it. We can get the results in less than 5 minutes based on the mesh size. So this is open source page for everyone. Everyone can access it, and it is actually the main purpose is it takes very less computational time which compared to the regular computational sources like ANSYS, OpenFOAM, etc. And the next one is, this is the greatest part in my funniest part in my internship. I actually performed and experienced this turning circle experiments. It is one kind of maneuvering experiment. In this turning circle experiment, we have tested the vessel under 3 different kinds of waves with 3 different types of frequencies and under 3 different types of velocities. So actually 9 set of different combinations we get from these experiments. So for these experiments, they have used wave probes, IMU and UWB sensors. Wave probes is the sensors which can give us the wave height, the wave height of the waves generated by the wave generator in the wave basin. This experiment was conducted in a wave basin of 30 meter cross 30 meter square section with 3 meter deep. So the actuator commands and the actuator commands means the propeller speed, rudder angle will communicate through ROS1 communication, and the ROS2 communication is used for the current rudder angle, current commands, the current rudder angle, speed, etc. to a software to Ubuntu OS placed in the computer, and the wave probe is connected to a software called Catman Easy, to a data acquisition system. So we measure the wave elevation, and we will get the slides, we get the plots for this turning circle experiment, the rudder angle, the velocities and all those, and they post process this with the results what they want. Next, we also perform the calibration of wave probe sensor. As I mentioned earlier, wave probe sensor measures the wave height of the waves. How it measures is, we place a wave probe sensor in a calm water for the calibration. In a calm water, and this wave probe sensor is connected to, as I mentioned earlier, Catman is a software through a data acquisition system. And we submerge the wave probe sensor in the calm water and with known under known heights. Like if my known height is 3, if I have taken 3 intervals, I will submerge first time for up to 3 meters, 3 millimeters, 3 centimeters height, and I will note down the values. So what we will do is, we will pass some current, some voltage to the rods. This is the last slide, sir. We will pass some voltage through the connecting rods, and the water in between the rods act as a conduction medium, and we will take the voltage readings from the software. If we submerge deeply into the water, the voltage readings will be high. If we lifted the wave probe from the water, the voltage readings will decrease. So from that we will calibrate, like we will use Excel and do the linear curve and get the constant. So this is the calculation and you get the constant. Why we do the calibration is because every sensor by performing experiments the results may get varied. So to confirm the accuracy, we will perform calibration for every sensor, even for the wave generators also. So from my internship, I interacted with so many people, so many professors. I also learned various things related to autonomous surface vehicle, which is very new for me. So thank you for the professors who supported throughout my internship. Thank you so much.